Okay, for what we have in the third lesson, we have regarding properties of exponents. And one property is going to be what is referred to as the product property of exponents. Now, when you hear the term product, you might be thinking of the operation of multiplication, which is true. But now, if you have expressions such as x to the m and x to the n, now these terms are multiplying together, but instead of multiplying the exponents, we wind up adding them together. So we have for x to the m times x to the n, this comes out to be x to the m plus n degree. And we have, just as a basic example, if I have x to the third times x to the fourth, that's going to be equal to x to the 3 plus 4. And the outcome is x to the 7th. Along with the product property, we have the quotient property. And just for what we have in the case of quotient, now we have what should come to mind is the operation of division. Say if we have x to the m over x to the n, this is going to lead up to the operation of subtraction between the powers. And so we have for x to the m over x to the n, we have equal to x to the m minus n. And for what we have as an example, let's say if we have x to the 10th divided by x to the 4th, and this is going to be equal to x to the 10 minus 4 degree, and we have for this outcome, this will end up at x to the 6th. So we have at the start, we have the product property and the quotient property. Also in the mix, we have what is referred to as the zero power property. And this states that if you have an exponential base x, which is non-zero in value, if x is non-zero, then x to the 0 is equal to 1. And just some cases here, like if I have an exponential base, say we have just with the number 5, like 5 to the 0 is equal to 1. And even if you have a negative value, such as negative 22, negative 22 to the 0 is equal to 1. And even if you have a fraction such as 1/4, 1/4 to the 0 is also equal to 1. And we have quite a few properties of exponents. And along with the product property, the quotient property, and the zero power property, okay, we have the inverse power property. So any non-zero value to the zero power is equal to 1, even if that value to the zero power starts out as a negative. Okay, now we have with the inverse power property, this will state that if we have x raised to a negative power, so we have x to the negative m, okay, that is going to be equal to the reciprocal of x to the m, which we have as 1 over x to the m degree. Okay. And we can say that, as an example, if we have x to the negative 7, that is going to be equal to 1 over x to the 7th. Also among the properties, okay, we have the power property of exponents. And this states, okay, so we have x to the m, then we have raised to the n. So you have a base raised to a power and then raised to another power. This time around, you're going to have the multiplication of the degrees. So x to the m, in turn raised to the nth degree, is going to be equal to x to the m times n degree. And just as an example, you have x to the 5th, in turn raised to the 4th degree. Okay, that's going to be equal to x to the 5 times 4. And the outcome here is going to end up at x to the 20th. And let's say that if we start to include more than just one variable, let's say if we have a product to a power property, so you have a times b raised to the m power. What's going to happen here to the m degree? Then we have each of the factors, so we have a to the m times b to the m. And we'll say just a couple of instances here. Say if we have 2x y to the 3rd, and we have raised to the 4th power. So we'll be looking at 2 to the 4th, and we have times x to the 4th, and we have with y cubed to the 4th, okay, that's going to be y to the 3 times 4. And for the follow through, 2 to the 4th, you have 2 times itself, times itself, times itself. So this will result as 16. X is to the 4th, and y to the 3 times 4. That will be at y to the 12th. And let's say that if we have just another case with the power product to a power property, let's say if we have 9 times x to the 4th raised to the 2nd. Okay, so you have anything that's inside the parentheses is going to be squared upon removal of the parentheses, so you have 9 to the 2nd. X to the 4th is going to be x to the 4th times 2. 9 squared is 81, and for the square of x to the 4th, that's going to be x to the 4th times 2, so that will be x to the 8th. So the square of 9x to the 4th is going to be 81x to the 8th. Now, let's say if we have the quotient to a power property, and this is going to state that if b does not equal to 0, then a over b raised to the m power is equal to a to the m all over b to the m. And we'll just take as a couple of examples. Okay, if you have 2/3 raised to the third. Okay, so this would be 2 to the third over 3 raised to the third. Cube of 2 is going to be at 8. And 3 cubed, 3 times 3 times 3 is going to end up at 27. And let's say that if we have x squared y over z cubed, we have raised to the 4th power. Okay, so you have x squared to the 4th, you have x to the 2 times 4. Y is going to be to the 4th. For z cubed to the 4th, that's going to be z to the 3 times 4. X to the 2 times 4, this will be x to the 8th. Y is already to the 4th. And for z to the 3 times 4, okay, that is z to the 12th. And we have, for our remaining exponential property, okay, we have what's going to be regarded as the reciprocal to a power property. And this states that if a does not equal to 0 and b does not equal to 0, again, we cannot have 0 valued denominators in the real number system. Under these conditions, if you have a over b to the negative m power, and again, this property is just another application of the inverse power. If you have a base to a negative power, and I want to put this in positive power terms, you would just take the reciprocal. In this case, this would come out to b over a raised to the m power. And we'll say that just for instance where we have the reciprocal to a power property, here we have 1/2 to the negative 3. Change that over, make this into a positive, so just flipping it, have 2 over 1 to the 3rd power. 2 over 1 is going to be 2 to the 3rd power, and this is equal to 8. Now let's say that if I have 2x squared over 5y cubed, and this is to the negative 2 degree. Again, if I make the negative 2 into a positive, I can flip this ratio. So we have 5y cubed over 2x squared raised to the 2nd, and squaring out everything. So we have 5 squared, y cubed squared, we have y to the 3 times 2. And we have with the denominator, bottom part of the fraction, 2 is squared, x squared is also squared. And for the final result here, 5 squared is 25. And y is going to be to the 6th power. 2 squared is 4. And for what we have in x, that is going to be 4th degree. So for 2x squared over 5y cubed to the negative 2, final result is 25y to the 6th over 4x to the 4th.